Hello, hi guys. Let me just share my entire screen. I hope it's visible. So today we'll be solving the daily question. I have actually recorded the video earlier, but somehow I didn't share my screen. So let's do the problem again. Okay, let me just clear the things. Okay. So pyramid transition matrix. So basically, you are stacking blocks from a pyramid to form a pyramid, and each block has a color which is represented by a single letter. So each row of block contains one less block than the row beneath it and is centered on the top. So basically, what it tells is if you have a block, particular blocks in order, then the very next block is just center of it and it's just less than one. Like if you see this block 1 2 3 4 5, so it has 5. So this particular block, rows of blocks should have 4. Similarly 3 2, and we will go to 1 all the way to 1 to get a pyramid. If you can see, so this is a perfect pyramid structure. Okay, well, let's go deep in the question. To make a pyramid aesthetically pleasing, there are only specific triangular patterns that are allowed. So triangular patterns consisting of single blocks stacked on the top of two blocks. The pattern are given as list of three strings allowed, with the first two letter uh, represent the left and right bottom blocks respectively, and the third one is basically for the top block. For example, if we have ABC, then C can be on the top of AB. So this is the whole meaning of this. And to start with the bottom block, so we should be starting the base with this bottom string. So as you can see, this is the bottom, and we need to tell whether it's possible to make it a pyramid or not. So if you can see, let's take this example. Okay. So if you can see, it tell that the bottom should be of PCD, right? So B, C, and D. So this thing makes the bottom, and we are telling that this BC can have C as a top, CD can have E as a top, and similarly C can have A as top, and FF can have F as a top. So basically, this BC can have this C, CD can have this C, CE this A, and this FF can be F. So what we need to do is we need to make the pyramid such that we are following this strictly. It doesn't matter really matter if we choose only few of them, but we should stick to this only. Okay. So as you can see on the top of B and C, you can use C. Okay. And on the top of C and D, you can use E. And we can see that this is having 3 as size and this is having 2. Okay. Now on the top of C and E, we can use A. So we are using A, and this has a size of 1. So we are able to achieve a pyramid with following these conditions and strictly following the size condition as well. Let's check out the other example, this one. So if we can see this example, it has four A's as a bottom, and we also has this particular map as A can be topped with B, similarly AA with C. So we can club these two up with this. Then we have BC can be paired with D, and BD can be paired with E, and DE can be paired with F. So we should now start looking at this. So we can see that we have two options for this particular two A's. Suppose we are taking, we again have two options for this 2A. Suppose we are taking B again, and we are taking C, for example. So as you can see, for the two B's, we can have E, and for this BC, we can have D. But you can see that we don't have any particular field for ED. We have for DE, but no for DE. Okay. So this particular thing is not a perfect, leading to a perfect pyramid. So basically we need to backtrack it. So basically backtrack and then try to put a B here. Okay. And now you can see that we have E, but this particular 2 is also is not present in the map. Let's say this is a map. Okay. So let's backtrack again. Now till the second B. Let's make it C. And the next, let's make it B. Okay. So CD can have D from here, and then the CB. So BC can have D, but CB is not present. So this is also not valid. So let's make it C. So we are basically exploring every possibilities here. So you can see we can find a D here, but we can't find any CC entry here. So it is also not possible. So basically we found out that, so basically what we are checking is every possibilities with this. So the possibilities were B, B, C, B, 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 C, B, B, C, C. Then we have C, B, C, 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 B. Okay. So as you can see, this is not valid. This is not valid. This is not valid, and you can check that all of these are not valid. So this basically leads to a false as an answer to this problem, and you can check here also it's false mentioned. So basically what could be our idea? Okay, so the idea basically becomes we have the base, we have the base tree, then we will check for every particular index along with its I plus 1 index. Okay, so we will check whether there is an entry in map. If there is, we'll just pick some of the values, suppose x here. Okay. Suppose this I and I plus 1 characters mapping is x and y. For the first place, we are taking x here. Similarly, we are picking till the value we got here. Okay. After that, when we see that if this is having a size of n, we are reaching a size of n minus 1. If we are able to reach, then we change our base to this particular string and make the same assumptions again. And finally, if we got a position where the base size is equal to 1, then we will return true because we are already getting the answer. And in the other case, um, suppose we didn't not able to get the 1 here, then what we'll do is we will backtrack. We'll basically remove this x, we'll put y here, and then again do the following steps. So there can be, to optimize the time complexity, what we can do is there can be cases like suppose we are at this position and we explored that at this state, taking this as a base, we didn't get to a true state. Then we will pick it and store it in a failed set. Okay. Then whenever in some other configurations we are getting the same as the base which is present in this field, then we will directly return false. So this way we didn't explore the false case multiple times. I hope this is clear. So we are basically dealing with this backtracking, and this will basically help us to achieve that answer. Let's basically go and code it. Okay. So basically what we need at the very first place is basically we should have the map. So map can we have pair of incoming, and so basically we should have a car. So what this map is basically means is basically it will be like this pair A comma B. We can store C on the top of AB. Let's make this map. Okay. So we will go to the allowed, and what we will store is map of E of 0 and E of 1 should be, so there can be multiple of them, right? So we should maintain it as vector. So we now have the map, this map I'm talking about, this map. So now let's go with the particular calling of DFS. So we have the bottom string, we have the next string which is currently empty. So next is basically the arrow string of base string. And we will have a particular index so that we can compare the two strings. This is I. So I is the index. Let's make this particular DFS function. So we will have bool DFS with a base string, and we will have a next string along with a particular index. So what is the base condition? The base string's size, that particular size is 1. Then we should definitely return it true here. Okay. So that's a base thing. Then the other case can be like we are taking whichever the particular allowed strings are there. So suppose the A, the first character is base of I, okay, and the base of I we can take it as car. Okay. So this is the first character. Then b would be base of I plus one. Okay. So then we will try for every possible character that can be at the top of this. Can get it from the map. So what we will do is next dot push back. We will push back this particular character E. So let's call it C. Can have C at the top. Then we will be doing the DFS call along with the base and the next. And index now will be the next index. And what optimization we can do here is if this particular call returns us true by any chance, so we should not explore more. So we already get an answer. So next dot pop back is basically we are backtracking. Suppose we are not getting answer here, true answer here. So we should not explore it. So we should backtrack and try possibly the next CV that's available. So basically this will help us to get. So one pleasant thing is in any configuration, if you are reaching a true state, then the answer is true. So we should only reach true state at least once. Okay. So this is the thing. So this will definitely work. But what optimization we should make here is I talk about this right. If we are getting any false state, then we should store it to get it optimized. Let's just do it. So if I am at any place, I am reaching a state that the next size is basically one less than the base size. That means the base is now completed and we have the it's now we have to make the next as a next base. So suppose this row is completed with checking all the things. Then the base should be at the next thing should make the base. Okay. So next is current base and we should also start fresh with this. So that's the recursion. And if this particular thing is false, then we should definitely put it in a set. This particular next. Okay. Let's make this set of string and this failed. And what's the base condition is basically if this particular failed set has occurrence of this next, that means we should not explore further, it's already a false state. Let's run it. Yeah, it's basically passing. Let's try submitting this. Yeah, it passed. So basically